All right, let's just review because we just had the weekend. The three figures we have gone over and the formulas that you'll need for Wednesday. Prisms over here on the left. We could have different kind of prisms depending on what shape the base is. Remember, whatever the shape the base is, that's what we call the prism. So for here, lateral area, I really don't have a formula for you. Remember what lateral area is. You take off the bases and you find the areas of all the faces that are left over. Probably going to be rectangles, though, let's be honest. All right, so it'll probably be number of rectangles times length times width. All right, it's probably going to be rectangles left over when you take off the bases. And then surface area. Now we put the bases back on, so I'm looking at lateral area plus how many bases in a prism? Two, right? So two, and they're both the same. And then just make sure whenever I write capital B, that means area of a base. All right, so that's the deal with prisms. Cylinders, these are actual formulas. All right, a cylinder, I do have an actual formula for you for lateral and surface area. Lateral area, pi dh. Think of it as circumference times the height, pi dh. And then surface area, we put those circles back on to the, here's my lateral area. Now I add on two circle bases, which each have pi r squared as their formula. All right, so pi dh plus 2 pi r squared. And then we had a little fun on Friday, and we introduced our pyramid. A reminder, pyramid has two heights. It has your Mission Impossible height, the height of the pyramid, and then the slant height, which is the height on one of the triangular faces. Please make sure we know the difference. So lateral area, we said, all right, if I take off the base, all I'm left with is triangles. 1/2 base times height times number of triangles. All right, number of triangles. So there's your lateral area of a pyramid. And then surface area, now I add that base back on. So lateral area, and again, notice I'm just putting 1b instead of 2b because there's only one base. And we went over Friday, hey, don't assume it's a square. You know, we threw one in you at the notes on Friday that was a hexagon. So be prepared to find the area of any type of figure. So there's the pyramid. And that was the assignment from the weekend. So talk to me here. I know I don't assign much anymore, but what I do, I expect to make sure we put some work into it. Just don't copy down the answer. Anything from, let's go, Eliona. What do you got for me? 23. All right, I just drew my own pyramid here to help us. I didn't draw anything. I copy and pasted. Who are you kidding? All right, so I'm giving you the surface area here is 24. So it's going to I know it's going to start out 24 equals because that's my surface area. The base area is 4 square millimeters. So that's, no, you didn't. That's my B, right? When I do surface area, let me do this first. Let me get rid of this. This is probably a little bit better. Surface area equals lateral. Let me start with the actual formula. Lateral area plus the base. Good? All right, 24 is the surface area. We're good. Equal to, it says, and the base area is 4. The area of this square right here is 4. What is the slant height of the pyramid? We know lateral area, 1/2 BH times, in this case, I'm going to have 4 triangles because it's a square pyramid. Go down now, I'm getting 4. So I know that's going to be times 4. All right, with my setup so far, because I'm going to add to it right now. I'm going to add to it. 24 equals 1/2. Now let's take a look. If the base has an area of 4 and it's a square, what must be each side length then? If I go 4 and 4, that's going to give me 16 for an area, right? The area of this square is 4, so what must be each side? 2 and 2. So that tells me the base of one of these, triangular faces is 2. So 1/2 base 2 times height. What do I call that height from Friday? That's my what? Which is what I'm trying to find. So I'll put h times 4 plus 4. See where all these numbers came from now. All right, now I'm solving for h. 24. Let me just, let's see, that's 4h plus 4. Move the 4 over, 20 equals 4h, h equals 5. So there's your slant height. Okay, that's a real good question. Should have put that one on the quiz on Friday, or on Wednesday. Anything else? We got a ton of time today. Notes will probably take 10 minutes tops today. We're all good? Anything you want to run by me? Again, everyone that came in here a little late, Wednesday is our quiz, and it's a shortened period on Wednesday, so we're going to start right away on Wednesday. All right, we're going to start right away. Okay, let me take a look. And then we got one more figure to talk about. That'll be on the quiz. And sorry, I'm not going to jump up on a desk today to show you this. I'll just show you this right here. We're going to do a cone today. A cone. I just want to make sure we're all good. Cone has a height and a slant height just like a pyramid does. Take a look at the diagram I provided. The height is just the same type of height as the pyramid. Comes from the apex. I don't even know if that's called an apex or not. I'm just making that up right now. Called the, up top, drop perpendicular to the bottom. And now because they don't have triangles as faces, cones, the side right there, that's going to be our slant height. So everyone see where it says L? That's what we're going to refer to as slant height. Not too sure why mathematicians call it L and not S. Maybe something's already reserved for S, sides, I don't know. But slant height's going to be L now for us. So you got a Mission Impossible height in a cone, and you have a slant height in a cone. And instead of, to complete that right triangle, remember we took half the base on Friday for the pyramid, we took half the base. Now we're just going to take the radius. Okay, we're going to take the radius. All right, lateral area. This is a formula I'm actually going to get because I can't take off if you take off the base of a cone, I have no idea what that's called, what's left. It's a cone still. So I'm just going to give you a regular formula. Pi r L. There's slant height, pi r L. Pi, pi, r for radius, L now again. Make sure we're good. L is slant height. That's what we're going to refer to as slant height. That's your L. All right, real quick, right underneath, you guys have an example. Find the lateral area of this cone in terms of pi. Find the lateral area of this cone. So formula I just given you, pi r L. Let's start hearing from some people. I can't win, Kara. 7. How about the radius? 4. Yep. So pi times 4. What's that 3 though in the cone? Is that my height or my slant height of the cone? The 3 that I gave you here. 5. What is that? That's my height, not my slant height. But I can find the slant height's going to be right here, L. So I can do that by I can find it using Pythagorean theorem. So go ahead, plug 3 and 4 in where they should go, and I'll have you guys find the slant height here for me. When you get the slant height, let me know. 6. 5. And it does say leave your answer in terms of pi for me. So go ahead and leave that answer in terms of pi. Lateral area. 1. Anna? 25. Good work. Any questions from you guys? Good time. All right. As I'm pulling this back up now, what about surface area? What am I adding on now? What am I adding back on? Surface area. What am I adding back onto this cone right now? 3 spent. Nope. Anna, what am I adding back on?
Pi r squared.
A circle, right? Everyone, I'm adding a circle back on. So it's going to be your lateral area we just went over, pi RL, plus add the circle back on, pi r squared. Find the surface, same cone, find the surface area now. So everyone transfer down that 20 pi we just found as the lateral area. We don't need to find it again. Plus pi, what was the radius? 4 squared. And now we're rounding to the nearest whole number. Band's warming up. Band is warming up. We're getting there. They got 2 more weeks before game day. And when you get it nearest whole number, let me know. Ho, 11. Yep. All right, we good? Look, guys, I'm not going to be in the business of holding hands today. I'll let you guys go ahead and practice on your own right now. Okay, so 1 through 4. Leave your answer in terms of pi. Be careful, all right? Make sure you know what you're given. Is it height or slant height? So numbers 1 and 2, find the lateral area in terms of pi. 3 and 4, nearest 10. Go ahead. We'll come back together in about 5 minutes. Okay, first question. You did Pythagorean theorem, and hopefully the slant height came out to be 104. Did it say simplest radical form? Nope. So you didn't need to bother breaking it down. It just said leave your answer in terms of pi. So your lateral area, pi times 2 times square root of 104. Now, a couple different ways you could have written that. You know, we could have had 2 square root of 104 with the pi. Make sure the pi is clearly outside the radical, not inside. Hey, if you did this too, if you did 2 pi radical 104, that's fine too. All right, but just don't put that pi, don't make sure that pi is not underneath the radical. But you had to do Pythagorean theorem to get that slant height of 104. All right, I'm just going to go through the answers. If you have a question where they came from, let me know. I got number, and maybe I did it wrong. Number 2, I got a lateral area of 136 pi. Pi times 8 times 17. Pythagorean theorem will get you the 8 radius of 8. All right, surface area for number 3, again, had to cut the 24 in half to find the radius. Pythag to find the slant height. 942.5 for your surface area. Again, here you go. Pi times 12 times 13 plus pi 12 squared, pi r squared. Anything there? And then 4. Here's my work for 4. Pi times 6 times 10 gives you the lateral area plus base pi 6 squared. So there's the form, there's everything plugged in for you. And then the final answer, 301.6. We're okay? Cone, that's the last figure on your quiz on Wednesday. Prism, cylinder, cone, pyramid. All right, you know how we end it. Let's smash 2 together and find the total surface area. What's the bottom figure? Let's start there. What's the bottom figure up here? Ooh, 7. What's my bottom figure here? Cylinder. All right, let's get to work on the surface area of that cylinder. That's a formula, pi dh, lateral area, plus, now usually I put 2 pi r squared. What's the problem? I don't want to put 2 pi r squared here. Why not? 8. Why don't I want to put 2 pi r squared? Yeah.
One of the surfaces is covered up.
Perfect. Surface area. You can't count what's covered up. It's going to drive me nuts on your quiz Wednesday. I can't count this base right here. It's being covered up. So all I'm going to do is plus 1 pi r squared. Usually it's 2 pi r squared, but Sophia just said that base is covered up. No go. All right, help me with the parts then. Help me fill it in here. Who's up here? 4. Let's go, boss. What's my diameter? 6. Height of the cylinder? 5. Plus pi. Radius? 3. Yep. And guys, I don't care what you do with what from here. Maybe you turn it into terms of pi. If you put it into a decimal, don't round that decimal because we still have to add it to whatever's on top of this thing. All right, so you want to leave it like that? Fine. You want to put it in terms of pi? Fine. You want to write it all out? Full decimal? Fine. The only thing I'm not fine with is rounding. Don't round this cylinder yet. So let's see. That's 30 and 9, 39 pi. I'll just leave it like that. All right, what's the figure on top now? What do we call what's on top? 1, Anna, what's on top? That's a cone. We just went over that one today. So pi RL, lateral area, clearly showing. Why am I not going to put plus pi r squared like I've been showing you today? 7, why no pi r squared, Kara?
Because the base isn't.
Base isn't showing. Cone's base is not showing. It's being covered up. So that's it. Just pi RL. All right, talk to me. What are my values here? 6, I know the pi. What's my radius? 3, slant height given? 5, yeah, no pi tag needed there. Cannot count what's being covered up. So 15 pi. I'll let you guys add them together. And what do we round it to again here? Nothing, huh? All right, we'll go nearest 10. We'll go nearest 10. We got to put some directions on there. We'll roll nearest 10. Oh, they're warm. They're warmed up already. All right, finish this off for me. Nearest 10th. What do you got? Oh, 4. Boss, what do you got? Darn right. Way to finish. All right, questions from you guys? Okay, let's get after it. Hey, just a little note. Make sure you pay attention to number 33. All right, number 33, I'm telling you the diameter is 15 in case there's any issues in the book with that. Okay, you can go online. Textbook pages are on Classroom now, so you can get it that way. Or if you just want an old school book, do it that way. I think we get out a minute or two early, not too sure, but